Hi, my dear Uncle Jimmy. Here I am. How are you? Groundwater and water wells is our seventh subject. My dear, for simplifying this subject, we'll divide it into six parts, such as Part A, groundwater; Part B, open water well; Part C, tube water well; Part D, maintenance well; Part E, water springs; and Part F, pumps. Let us see together. Part A, groundwater. It is one of the major elements of hydrological cycle on the globe, forming one of the main water resources in any country as underground store. Many references presented the distribution of groundwater on the earth as 12.87 and 10.53 million cubic kilometers for saline and freshwater respectively. Moreover, the fresh quantity represents about 28% of the total fresh water on the earth. Take in consideration that this approximately percent is continually decreasing, referring to the weather impact phenomenon. Precipitation represents the main source of subsurface reservoir, as rain falling on the ground surface and percolate down, forming groundwater. In addition to the penetration portion of filtration and sewage water from rivers, lakes, dams, and different hydraulic structures. Groundwater travels its course from discharge to discharge area and logically undergoes some chemical and physical change, referring to its reaction with the minerals in the carrier subsoil layer. Generally, the subsurface water can be found in two main tomb zones. The upper strata is known as aeration zone, which is meaning unsaturated. Subsequently, by an saturation zone, where all of its pores are filled with water, forming the groundwater. Figure showing the feature of subsurface geological formation and different locations of tapping water wells. A geological saturation formation or strata with transmitting an appreciable quantity of yield water is known as aquifer, and where the groundwater flows through it is assumed to be predominant horizontally. An aquitard is a strata having porosity but limited permeability. Hence, it permits an unapplicable quantity of water, and the groundwater flow through it is assumed to be predominant vertically. On the other hand, aquiclode is an impermeable geological formation containing water but not capable for transmitting or supplying a significant quantity of water. Moreover, aquifer is an impermeable geological formation which neither containing nor transmitting any quantity of water. Anyway, homogenous is known on aquifer or aquitard when a location has the same hydraulic conductivity through the water bearing vertical layer, while isotropic is known when in either case has the same hydraulic conductivity in all directions at a particular location. Types of aquifer: geological formations which are bearing and saturated with water and forming a huge reservoir of groundwater scientifically are known by different names according to its expressions, such as unconfined, confined, and leaky aquifer. Unconfined aquifer, which is known as phreatic or water table aquifer, which water table boundary is the upper surface, while boundary by an impermeable strata, aquifers, as its lower surface. Anyway, perched aquifers are the special case of an unconfined aquifers and occur when an impermeable strata of limited area in a form of land is located as a special case of unconfined aquifers, and so creation and groundwater above it and separately than the saturation zone. confined aquifer, which is known as artesian or pressure aquifer, and boundary by an impermeable strata aquifer at both its upper and lower surface, similar to a pipe, which for this reason is known as confined one. Moreover, the confined aquifer gradually changes into unconfined phreatic aquifer, which form the recharge zone and where the rainwater reaches the water table. Semi-confined aquifer, which is also known as leaky aquifer, is bounded by impermeable strata aquifers at its lower surface, while bounded at the top by soil layers of relatively low permeability aquitard. Physical properties of aquifers. Indeed, estimating the physical properties of water bearing layers are very important for taking the right decision of excavation the groundwater reservoirs in any area. The capacity of aquifer of containing water is measured by its volumetric porosity. However, a high porosity not considered a rare indication of large yield of water because the yield is only which can be drained by the gravity, as shown in the enclosed equation. The saturated thickness of an aquifer is ranged from several meters up to hundreds or even thousands meters. Transmissivity is the rate of flow under a unit of hydraulic gradient through a unit weight of a pipe cross-section and can be derived as shown in the enclosed equation. Moreover, the storage coefficient or storativity is the volume of water released per unit surface area of an aquifer under a declined unit of head. Anyway, silica yield of aquifer is expressed to the ratio between its effective drainable pools volume to its volume as shown in the enclosed equation. Specific yield balance on grain size, shape, and distribution of pools in the aquifer and generally ranges between 10 up to 30% for clay and coarse sand deposits respectively. Silica retention of an aquifer is the ratio between the volume of water which can be retained due to the molecular and capillary forces to its own volume, as shown in the enclosed equation. Safe yield of an aquifer is the volume of water that can be withdrawn from its storage capacity without causing any negative hydraulic balance, as if this negative balance occurs, many problems may be occur, such as lowering the level of storage water, increasing the cost of lifting water, reduction in the yield, and or deterioration of water quality aquifer. Moreover, the hydraulic resistance is the resistance of an aquifer to vertical flow either upward or downward and can be derived as shown in the enclosed equation. Leakage factor is the leakage through one or two aquitard confining an aquifer and can be derived as shown in the enclosed equation. It is expressed in meters as large values may be caused by high transmissivity value of aquifer and or a high hydraulic resistance value of aquifer, and so this factor should be small for obtaining a significant yield from the confining aquifers and its kind. However, pumping test and hence what report clear slope is a simple way to recognize the sublayer characteristics by pumping water from well tapping the aquifer and measuring the different available water discharge and the drawdowns of water static level inside the well and the piezometer, which will be fixed at known distance from each well at this time. Goodbye.